Okay, the midterm exam could be due March 31st by noon. Gives you 2 weeks and a day. Okay. I just emailed a copy of a preparation document. Preparation document has pretty much every type of problem you can expect to see on the exam. Now you want to read the information in the preparation document because there are problems on there that aren't going to be represented on the exam. Okay, they're coming along just a little bit later. Not going to say too much about it right now, except that you're going to pass the course, you got to pass the exam and the midterm and the final exam. Okay. Reason we have the deadline March 31st is that's the last drop out day. Now, I don't think that there's any reason that anybody should necessarily drop this course, even if you're not find that you're not on track to pass it. Okay, because you're either going to get a U or a W. Neither one of them affects your point average. I don't think one of them looks that much worse than the other. Okay. And they don't look great on your transcript, but they don't really hurt that much in the long run, especially if you're ultimately successful in your math classes. Okay. So, but what you get if you pass the course is a recommendation to go on and attempt the pre-calculus with the support course. That's what this course is designed to do, give you the background you need for the pre-calculus with support course. Okay, so you definitely want to try to pass this course. That looks pretty good. Okay. It also opens a lot of doors for you. It gives you the preparation you need to be successful in the pre-calculus sequence or another math course. So there's your reason for taking this course. There's your reason for wanting to pass it. So that's it. I'll provide more detail later, but that's the situation. There isn't quite as much on the test due to all the weather glitches and everything. We've had to make modifications to the schedule for the course, which has caused modifications to the schedule for the distance course. The distance course needs to have a schedule that's a little later than the schedule for this course. So theoretically, they can use the videos for this course a couple of days later. So the last thing that will be on the exam is the stuff that's going to be due this week, exponents. Okay. Now that's something with practice everybody can get pretty good at. But then everything up that we've done up through now and exponents will be the topics that are there represented on the exam. The exam is in the testing center. The exam has to be taken under supervision. It's in the syllabus. Hopefully everybody's aware of it. I always have distance students who say, well, can I just take it at home? No, you can't. Because 90% of the people who take the exam at home are going to use AI to do their exams. Okay, that's all there is to it. That might not be 90%, and there are people who would do it honestly, but we can't assume that. That's not going to happen. We can't assume everybody who takes a test at home is going to do it honestly, because we find that there's just too much dishonesty. That's all there is to it. So we have to take the test in a community college testing center. If you happen to be closer to a different college, would like to take it at their testing center, let me know right now. Your distance student especially. If you're on campus, I assume you can get to the testing center and take the test there. I'll say more about it as time goes on. And if you have questions, email me or ask me. Okay. And as I said, I just emailed out the practice document. It'll also be at the assignments page. And I'll try to even get you, for the class students, at least a hard copy by next time, okay? Okay, so we're gonna go on now. Distance students, I hope you've been doing as recommended. Taking the quizzes, using the quizzes as practice. If you understand everything on the quizzes, probably going to be in good shape to at least pass the test, because most of the content of the course can be accessed through the quizzes. You know, what distance students are asked to do is take the quizzes as if you were in class, consulting your notes without going to AI, without looking at a text, and see how you do. And then if you don't do well, watch me go through it. That's what I'm going to do now. Okay, so we have this system of equation, 3x minus 4y. Well, 5x plus 6y equals 30. Now, you can easily enough match up your x or your y coordinates. If I multiply this equation by 5 and this one by -3, what's going to happen? I'm going to have 5 times 3x here, which is 15x, and -3 times 5x, which is -15x. If I add the equations, the x's go away. It's something you should be very familiar with, having done the homework. Okay? Or I could multiply this one by, well, I could multiply this one by 6 and this one by 4. Okay? It'd be a little easier to multiply this one by 3 and this one by 2, which will accomplish the same thing. And I could eliminate y. Before I do that, I'm going to sketch a graph. Just give myself an idea what the solution ought to be. So if I get something that's completely off the wall, that means either my graph was off or my solution was off. You know, you get some fractions in this thing. You know, I didn't hold back on nasty fractions this time. A lot of times I contrive them so that you get whole number solutions or easy fractions. I didn't do that this time. Okay, so this equation has an x-intercept that occurs when y equals 0. And that's a basic principle that I've repeated many times during this course. Okay, to find your intercepts, the x-intercept occurs when y equals 0 because the x-intercept is on the x-axis, and that's where y is 0. So if y is 0, you get 3x equals 12, x equals 6. So we know this is a line x equals 4. Right there is the x-intercept of this equation. Now, the y-intercept occurs when x equals 0. Well, if x equals 0, we're left with -4, y equals 12, so y would equal -3. So I'm going to draw my y equals -3 line here. Y-intercept here, down until I get the board with my knuckles. That was a relatively straight line. Okay, so there we have straight line representing this equation, and I want to label that. You know, we want the information on the graph. Now, the second equation, if y is 0, you're going to get x equals 6. So the x-intercept is 6. Well, 4 is here, 6 is here. I'll just say here's x equals 6. And here's the x-intercept of this graph. And the y-intercept occurs when x equals 0. X equals 0, you get 6y plus 30, so y would equal 5. Now, so if that's -4, then 5 is going to be over here. Let's say y equals 5 here. Then here's our graph. And here's our point of intersection. A whole lot like it may be about equals 5. Looks about halfway between. It's an hand-drawn graph. It's not going to be exact. And that's a little more than x equals 1. I'm going to say 1.5. Now, if I graph that correctly, my solution should be somewhat close to this. Well, now let's go ahead and perform the elimination. Okay. And I've recommended that everybody do exactly as I do until you get your feet wet on these equations, on these problems, so that you can clearly document what you're doing. I'm going to go ahead and eliminate x. I'm going to multiply the first equation by 5. The second equation by 3. So I'll multiply the first equation by 5. I get 15x minus 20y equals 60. And negative 3 times the second equation gives me negative 15x minus 18y equals negative 90. Then when I add the equations, 15x and negative 15x gives me 0. Negative 20y and negative 18y gives me negative 38y. And when I add these, I get negative 30. So I get y equals negative 30 over 38, which is negative 15 over 19. Now that's approximately equal to 0.8. Well, that doesn't agree real well with my estimated y-coordinate here, which is 1.5, but it's not that far off. It could be that my 6 was a little too far out here, and this point really should have been a little closer to the x-axis. In any case, there's a tentative solution, okay? And there are things I can do to get that solution. But what I'm going to do is I'm just going to take that solution. I'm going to take the fraction. I'm not going to take the approximation. The only reason I made this approximation is so I could compare it with my estimate. Okay. We don't use approximations to get exact solutions. So, as I've done many times before, I'll just go up to the most convenient equation here. Again, negative 15/19 for y. I get 3x minus 4 times negative 15/19 equals 12. Well, I multiply both sides by 19. Now, negative 4 times negative 15 gives me 60 over 19. So I go ahead and do that multiplication. That could be done in 2 steps if we prefer. Okay, so we get this. Well, that gives me 19 times 3x plus 19 times 60 over 19 equals 19 times 12. And that's 57x plus 60 equals 19 times 12 is 190 and 38, which is 228, if I'm doing my arithmetic correctly. Okay. So now I get three dots. I'm going to subtract 60 for both sides, and I'm gonna get 168 here. Now, this isn't matching up all that well with my graph, because my graph clearly gives me an X value greater than 4. If my X-intercept really is 6, which it is, my Y-intercept really is 5, okay? And then the X-intercept there is 4. Something's probably wrong. Because if I divide this out, I get less than 4. Which makes me think I'd better go back and look at the numbers I put in my solution. This is a correct method. That we would get then X equals 168 over 57. Okay. And that's actually a little less than 3. It's kind of close to 3. Doesn't seem to work. So did I do something ignorant up here? Let's see. The multiplications seem right. That gives me 15, that gives me negative 20, that gives me 60. This gives me negative 15, this gives me negative 18, this gives me negative 90. 20 and 18 is 38, they're both negative. That's negative 30, so that seems okay. Patients are right. So something is a little bit haywire. Now, I'm not going to go back and do all the details of the checking because these fractions are pretty nasty. At least all that nasty is what I can do in my head. If it's reduced down to something over 19, I'd be happy with it. And 3x would be like 9. Okay. This should have been negative 0.8, which means that my intercept would have been below the axis, and that really doesn't make sense in terms of my graph. I'm seriously wrong, but there's the method. Okay. In order to look at this a different way, they did say solve by graphing, solve by substitution. Let's solve by substitution. Now, let me just back up and say, if you do everything that I did here, if you start here and do everything accurately, use your calculator if you need to, the numbers should work out. Okay, there's just some bonehead arithmetic mistakes that I've made here, which is causing this not to work out. And it has to be there because I certainly don't see anything wrong with my graph. Okay, substitute. Take the first equation. Let's write them down. X equals 4/3 y plus 4. Then we plug this expression into the second equation. So we've got to come around here, this in here, which is going to come down here and give us get this equation, replace x by this expression. Multiply through. I'm going to do it in 2 steps. First, I'll multiply the 5 through this expression using each standard law. Then I'm going to multiply both sides by 3. And I'm just going to do 3 times this plus 3 times this and 2 times this. See, times 20 thirds y plus 3 times 20 plus 3 times 6y equals 3 times 30. 3 times 20 thirds y gives me 20y. I've got 60, here I've got 18y, and here I've got 90. This gives me 38y. I'm skipping the step where I subtract 60 from both sides. So if I subtract 60 from both sides, I'm going to get 30 over here. 38y equals 30, just like negative 38y equals negative 30. This tells me that y equals 30 over 38. (15 over 19). And now I see, and I was careless about negative signs. There's a negative here and a negative here. Should have been negative 30 over negative 38. This, and it should have been plus 0.08. But it's going to be 15/19. Now here I have negative 15/19. It should have been positive. So it should have been negative 16/19 here. In other words, this should have been positive, not negative. So I multiply negative 4 by 15/19, I get minus 60 over 19. That's going to change my result down here and give me something almost certainly it's going to be reconciled with my picture. All right, so fortunately, these are fairly simple things to fix. So this term comes from this one, so it's going to be negative instead of positive, which means this 60 will be negative, which means now I'm going to get 288. So that now I get x equals 7, which is approximately 5. And it's really pretty close to 5 because 5 times 67 is 285. Okay, it's like 5 and 357 is 5 and 1/19. And that'd be like 5.05. Okay, so now I've got a solution that says 5.05, 0.8, which is reasonably close to my graphical solution. And we've seen solution by elimination with a mistake, a sign mistake here. Careful about your signs like I'm not. Okay, And in the process of messing up the sign there, I got something that couldn't do. My graph told me it couldn't do. I could have taken these numbers and plugged them back in and found it wouldn't do. Okay. Went to substitution, see what happened. And that's where I discovered my error. Okay. Now, if I take that 15/19 and plug it in, well, I could plug it into the first equation, I'll get the same thing I've got here. I get the same thing. Notice I'm doing substitution. I get my y value. First, I solve one equation for x, plug that into the other equation, and solve, and I get the value of y. Once I've got the value of y, plug back into either equation, I get the value of x. Okay. So that's as much survey as I'm going to take time to do today because we had some technical glitches at the beginning of class. The first time in history, my Wi-Fi wouldn't connect because my Wi-Fi was turned off. So finally took it to technician. Took him a couple of minutes to get it turned on. I said, "What'd you do?" Turned to me and said, "Well, I'm telling you." Some kind of secret. He did something. Anyhow, so for those reasons, I'm going to leave it at this, but this should be clear about all three methods. Demonstrate all three methods. Should demonstrate the very fine usefulness of a graph. If you're sure your graph is right and your solution is nowhere near, then double check your graph. And put your solution. It's usually easy to solve these, to graph these by intercepts. So it's usually easy to create a quick graph. Substitution isn't as important for linear equations as it is for other equations, but you need to learn the method because you run into other kinds of equations. Elimination is most important for linear equations. And it kind of gets stressed in this course. Later courses, though, you have to use substitution, so you do need to understand the whole process. Okay, so you're just a student, what do you think each of these is? Okay, now let's work it out. What does x squared mean? X squared means x times x, right? Everybody understand that? X cubed means x times x times x. Now you could have written that down, couldn't you? You knew that. Okay. But of course you're hung up, well, how do I get the answer to this? Well, one thing to get the answer to this is, what you can do to get the answer to this is write down what that means. It's times this. Okay. And of course, that means the same as because these are all multiplied, it doesn't matter how they're grouped. You multiply them in any order, just a bunch of things that are multiplied by each other. And what's that equal to? That's x to the fifth. Okay. So we could say that x to the fifth equals, x squared times x cubed equals x to the 2 plus 3, which is x to the fifth. Now, why is it 2 plus 3? It's because we've got 2 of them here and we've got 3 of them here. That gives us 5 of them, right? Okay. So if you just break it down and write all the x's out, you get it right. Okay. Now, if I ask you, what's x to the 57th times x to the 283rd? Well, it wouldn't be practical to write out 57 x's and 283 x's, but you could, right? You could write them out and then you could count them all. And if you did all that accurately, you get the right answer. But that's x to the 57 plus 283. And you don't have to write them all out. You know that if it works for x squared and x cubed, it's got to work for x to the 57th and x to the 283. You can visualize writing that out and see what it has to be. You don't have to quote some abstract rule, although it's good to remember the rule. I promise you, when I learned this stuff, when I got to this very good algebra student, when I learned this stuff, I always kept this in mind. Because when I tried to apply the rule, I thought, okay, which rule is it? Because the other rule is similar to it and easily confused. And for a while, I would always think back to this example and this example. Okay? To make sure I was doing it correctly. Okay. Now, let's try x squared. What's that mean? Well, that means x squared times x squared times x squared, doesn't it? When we cube something, we multiply by itself 3 times. Well, we multiply by itself then again. But we have 3 of them. Okay. And that equals x times x multiplied by x times x multiplied by x times x. And now, just a series of multiplication. We don't need parentheses anymore. We can write it out like this, and there are 1, 2, 3, 4, 5, 6. So x squared cubed is x to the 2 times 3. Why 2 times 3? You got 3 of them, and each of them have 2 x's. Right there, 2 times 3. Staring you right in the face. If you just remember to write that out. Now the rules are x to the a times x to the b equals x to the a plus b, and x to the a to the b equals x to the a times b. If you try to memorize these rules, you're going to get them confused because they look so doggone similar, unless you have a really good photographic memory. Okay? But if you go back and let a equal 2 and b equal 3, you can see whether you should add them or multiply them. Okay? So if you understand this, you understand these rules. If all you do is memorize the rules, you don't understand anything. You just take a wild guess, hope you got the rules right, and hope it comes out right. Okay? And you might be good at that. You know, it's very possible to be good at that. I don't think it's very reliable, in most cases, but for some people it is. If you're one of those people, then, you know, what I'm concerned about is you get it right. I really do think it's good to understand the reasons why though. All right. Now, there are a couple of other rules. Let's do x to the fifth divided by x squared. I could write this as x cubed times x squared divided by x squared. Now that it's equal to x cubed. So I can say that's not as obvious as these rules, but it looks kind of similar to this rule. Okay, where this rule is a multiplication, this rule is a division. When I multiply, I add the exponents. Okay. When I divide the exponents. So I get the rule x to the a divided by x to the b equals x to the a minus b. Okay. You can just use this rule by comparison with this rule. If you can understand what I did here, you see why the rule works. And open math is going to give you an explanation of that too. And examples. So these are the main rules you use in dealing with exponents, but they can get a little more complicated. So let's just see what happens. Let's say I wanted to do x squared y cubed over z to the fifth squared. And it turns out you're just going to square everything here. Okay. So that's going to give you x squared times y cubed squared divided by z to the fifth squared. Okay. I square the whole thing, that means I square every factor. Okay. That's only if these are multiplied and divided. If there are additions and subtractions in here, it's more complicated. Okay. If everything's multiplied or divided, you can do this. And of course, now you know from your rules, the x squared squared, well, you can even visualize that. That's an x squared times an x squared, which is an x times x times an x times x. There are going to be four x's there. That's going to be x to the fourth. And y cubed squared. Well, actually, I'm gonna write this out according to. But you understand why do you get y to the 3 times 2? It's because you got a couple of y cubes, right? And each y cubed has 3 y's in it, and you got 2 of them, you're going to have 3 times 2 y. That's x to the fourth, y to the sixth, divided by z to the 10th. And you're gonna see stuff like this, but it's a pretty easy transition. Until you get pluses and minuses in here, then you're in a whole different ballpark. We're not dealing with that at this point. Okay. So as I always urge, don't do every problem with a video or an example in front of you. When you get down to the problems that don't have videos, work them without looking at anything. Work them based on what you learned in the problems earlier. Okay. And if you can't, I'll go back and try to learn what you didn't learn. So the next problem you can do without having to look back. So by the time you get to the end of the assignment, you know, you come into class and do some of the I'm going to ask you to do next. And yeah, generally you're pretty good at doing that. Okay. Just try to nail it as best you can. And this, especially talking to distance students too, you know, I don't get to see your work. You send me work, but I don't really know all the details that went into that work. And if you're shortcutting the learning process, now's the time to really focus on reviewing and learning. You should be able to go back and do all the quizzes that we've done practically every class. Okay, that'll be a good place to start reviewing. And then the document that I just sent out. Okay, so begin preparing for the quiz. 2 weeks passes before you know it. And if you went the night before, you're not going to do nearly as well as if you spend a little time each day reviewing one topic or the other. So good luck and let me know if you have questions, and I'll see you next time.